Welcome to the next session on ANSYS Workbench tutorials. In this session, we will analyze a circular CFST column for its modal analysis. We will start by double-clicking on Modal module. First, we'll go to Engineering Data and double-click. Here, we'll add the material concrete M30. The density of this material is 2300 kg per meter cube. Next, we'll give the property of isotropic elasticity. Young's modulus in megapascal is 25 and Poisson's ratio is 0.18. Next, we'll add one more material, which is steel. We'll give the value of density, which is 7850 kg per meter cube. Also, we'll give the property of isotropic elasticity. In megapascal, it is 200 E3. Poisson's ratio is 0.3. So once this is done, we'll go to project and update project. Next, we'll go to geometry and right click. New design modular geometry. We'll first go to units, millimeter, XY plane, look at. We'll go to sketching and first we'll draw a circle. This is the inner material, which will be concrete. So I'll give the dimension for this one, which is 480 mm. I'll click on look at. Then I'll go to modeling, extrude. I'll select the sketch one, apply. I'll give the depth as 2000 mm, which is 2 meter, and generate. You can see here. Again, I'll click on look at. I'll go to the XY plane. I want to create a new sketch. Sketch 2. I'll go to sketching and choose circle. First, I'll draw a circle to this dimension itself, and then I'll draw one more circle such that I have a hollow cylinder. So I will give dimension to the outer one, which is 500. Then I'll go to modeling and click on extrude. I'll select sketch 2, apply. The depth is 2000 mm. Operation, instead of add material, I'll choose add frozen and generate. You can see here there are two parts, two bodies. This is one solid, which is the inner one, which will be concrete, and the outer one is going to be steel. So if you want, you can rename this over here as steel, and the inner one, I'll rename this as concrete. So now the geometry is complete. We'll close this. We'll go to model and double click. I'll first go to geometry. You can see here, this one is concrete. It's now very easy to allocate the material because we have already renamed the solid. So you just have to select the solid, go to material assignment and select the material that you want to allocate. Next, I'll go to mesh and generate. So you can see here the meshing is too fine. Now, since I'm using the student version, there will be a problem. So I'm just changing the units to meter and changing the default size to 1 and generating once again. Then I'll go to modal, right click, insert, fix support at this end. I'll select the face option. So these two are fixed. Apply. Next, I'll go to solution, right click and solve. You can see here these are the 6 modes for which you have got the frequency. Just select here, right click, create, select all, right click, create mode shape results, go to solution and solve. Now you can see there are 6 deformations for these 6 modes and its corresponding frequency is also given. So we'll go for the first one. We'll just animate and check the result. The maximum deformation is 0.065529 meter. Now you can change this to millimeter if you want. So you can just go to this option, select millimeter. It is 65.529 millimeter. And the frequency is 51.37 Hertz. Now, as we are already aware, modal analysis is basically used to know the natural frequencies of the body of higher order such that we are able to avoid those frequencies when the body is in actual application. So this is one of the frequencies to be avoided and the rest of them are mentioned here. Now if you don't want to see the mesh, you can go to edges and select no wireframe. You can see there are bands formed. If you don't want to see the band, you can just select smooth contours such that the colors blend into each other. You can click on max min to know where the value of deformation is highest and where it is lowest. If you don't want to see that, just click on max min once again. You can use the probe option to move over this body and figure out the value of deformation at a particular point. So that's how you see the results. Now we'll go for the second deformation. Again, you can animate and check the pattern of its motion, which will be different for all 6 of them. Here the maximum deformation is 65.641 mm. Frequency is 51.4 Hz. Now the first and the second one have very close frequency. So this is the pattern of its motion, which is different from the first one. Now we'll see for the third one. Here you can see the total deformation is 89.653 mm at a frequency of 106.62 Hz. This is almost double the first and the second frequency. So here you can see a different pattern of motion. Then we'll go for the fourth one. Again, we can animate and check the results. Just observe the pattern of its motion. The frequency is 115.19 Hz. Now, the difference between third and the fourth frequency is not that much. It's just a 9 Hz difference. But yet you can see a difference in its pattern of motion and the value of deformation highest is 79.012 mm. For the third one, the highest deformation is 89.65 mm. You can see it is greater than the fourth one. Then we go for the fifth one. Here the frequency is same as that of the fourth one. Hence the value of deformation is also close. But what is important is its pattern of motion. So just animate and check the result once again. Then we'll go for the sixth one. Here you can see the maximum deformation is the highest one, which is 114.51 mm. And the frequency is 125.77 Hz. So you just have to avoid these frequencies such that this frequency is not tapped and you're not getting into any resonance. So here you can see the pattern of its motion. Now why did we get only 6 deformation? Because if you go to analysis settings, max modes to find is 6. If you want to increase, here you can click and you can increase as many number of modes that you want. And then you just have to click on solve. If you don't want to do that, you can leave it to 6 itself. So that's how you check the deformation and the frequencies at the particular mode. You can animate and check its pattern of motion. So with this, I end the session. I hope you have understood the modal analysis of a circular CFST column. If you have any doubt, please write to me in the comment section. Don't forget to like, share and subscribe to the channel. Hit the bell icon for latest video updates. See you in the next session. Thank you.